Okay, good day guys, and let's do another questions on the mole concept calculations. Alright, so this is questions about this mixture of ammonia and oxygen is passed over heated platinum, and the nitrogen oxide and water are formed. Fair enough. And we are required to find the values of x and y. Alright, okay, let's do part A first. Okay, we have 4NH4 NH3, sorry. Alright, so it's ammonia. Ammonium will be NH4. Alright, ammonia is NH3. Alright, so and plus XO2, right, that will give you Y and O. Okay, nitrogen oxide and 6 mole of water, H2O. Okay, and we are required to find the X and Y. And this is just a balancing of equation, that's all about it, right? So for you to find the y and the x, okay, let's try the y first. Alright, you can see that just focus on your nitrogen. The products is nitrogen oxide and water, and here we have only ammonia, right, and oxygen. So nitrogen here is only 4, so y has to be 4. Okay, when y equals 4, right, what will happen to your x, right? What will be x be? What will x be? So if it is 4 here, that means oxygen, there will be 4 and 6, so 10. That means x must be equal to 5, right? 5 times 4, I mean 5 times 2, 10, isn't it? Right? So there will be 5 here, so x will be 5. That's all, right? Simple. 2 marks. Very generous, isn't it? Okay, part B, calculate the volume of oxygen needed to produce 200 cubic cm of nitrogen oxide. Okay, we are just focusing on oxygen and nitrogen oxide, right? To produce 200 cubic cm of nitrogen oxide. Okay, so this one is 200 cubic cm, right? And we will need to know how much oxygen, what's the volume of oxygen, right, will be produced or needed, right? What's the calculate the volume of oxygen needed to produce 200 cubic cm of nitrogen oxide? Simple, very simple, because the ratio is 5 is to 4, right? Therefore, that means in other words, 5 cubic cm of oxygen will produce 4 cubic cm of nitrogen oxide. So if you want to have 200 cubic cm of nitrogen oxide, so 200, right, divided by 4 times 5, right, that will give you your, this one is 550, so 50, so that means 250 cubic cm of oxygen, right, is needed, right? 250 cubic cm of oxygen is needed to produce 200 cubic cm of nitrogen oxide. 2 marks. Good. Now part C is very interesting. This is where most students will get confused, because they said air contains 20% of oxygen by volume, right? 20% oxygen, 80% other gases, right? Calculate the volume of air needed to produce 200 cubic cm of nitrogen oxide. So we need to produce again 200 cubic cm of nitrogen oxide. Of course, it is corresponding to 250 cubic cm of oxygen, right? Now we are given that air contains 20% of oxygen. That means we can also say that 100 cubic cm of air, right, that will be corresponding to 20 cubic cm of O2, oxygen, right? So we know that we want to calculate the volume of air needed to produce 200 cubic cm of nitrogen oxide, but we don't use 200 cubic cm of nitrogen oxide, because 200 cubic cm of nitrogen oxide is corresponding to 250 cubic cm of oxygen. Therefore we just put here 250 cubic cm of oxygen, right, of O2, right? So that will give you the volume of air, right? The volume of air needed, right, to produce 200 cubic cm of nitrogen. Okay, so as I said, we don't use 200 cubic cm of nitrogen, we use 250 cubic cm of oxygen, right? Okay, therefore the volume of air needed, right, will be equal to 250 divided by 220 divided by 20, sorry, right, multiplied by 100 cubic cm. Done deal, right? Cancel 2, and this one become what? 50. So 25 times 50, that will give you 1250 cubic cm of air. That's all. Simple, very simple. Alright folks, that's it. No formulas, alright? Anybody tell you to memorize formulas for mole concept calculations, tell them to fly kite.